afternoon. I feel a word of congratulations is in order, your last breakout session for NDC London for this year, so well done, you've made it. Right, so this will be a fairly leisurely session, so I'll try to keep it quite high level. We'll run to about 45-50 minutes, so I'll leave plenty of time for questions at the end. But the major question we'll look to answer today is how do we as API developers choose between GraphQL, gRPC, and REST? So to get to that answer, we're actually going to do quite a few things. So we're going to go through, first of all, a tour of API styles, and we'll look at them over time. If my clicker was working. So API styles over time. And what we're going to do from here is get an idea of how the thinking in our industry has evolved. And we're actually going to start about 20, 30 years ago and then look at all the major technologies that we've seen along the time. And we're going to see where they're different and actually where there's a lot of similarity between them. And we're then going to take a bit of a pivot and we're going to look at how we actually make architectural decisions. So we're going to look at the properties which we'll want our systems to expose or imbue. And then we'll look at how we make decisions or implement constraints which will then yield those properties as well. So very much an outside-in view to it. So with that context set, we're then going to look at a few of the conversations that are happening in the API industry today and take some of the rather blanket black and white statements and peel back the covers and then see how they actually really weigh up. So add a little bit of nuance to each one of those points. So again, allowing us to make a more informed decision such that if you look to choose one of these API styles, maybe in your company or again, maybe in your own time, that you'll be able to make a more informed decision. And finally, with that knowledge, we're then going to look at some sample scenarios and then choose based on that, maybe what's the simplest or the most appropriate one to choose. So before all that, a little bit about myself. So my name is Rob Crowley. I am the head of engineering for a company called Vista Technology, so automated fare collections, very similar to the Oyster card that you might be aware of in London. And previous to that, I was a principal consultant for Telstra Purple in Australia. So pretty much my entire career has been in designing, operating, and running distributed systems. So APIs are very close to my heart. I'm also the co-organizer for DDD Perth, the largest IT conference in Western Australia. So about 800 attendees every year, so that's grown beautifully. And I'm also available on the socials at Rob D. Crowley. So if there's any questions that come up throughout the session, or if you'd like to get in contact, maybe you've taken one of the ideas and run with it, please reach out. I'd be absolutely delighted to help. So I'd like to share a little bit about why I'm giving this talk today. And I really have to confess, it's a slightly selfish motivation because my Twitter timeline is an absolute tire fire. You see, when I joined Twitter, I started really about the same time when my interest in REST started, and I followed Mike Amundsen, Eric Wild, and a whole host of other luminaries in the API space. And it was very much all this REST-orientated content that I was getting. And everything was going grand for about 4 or 5 years until 2015, and GraphQL got released. I started following a whole host of new people. It turns out these groups don't agree a lot. So suddenly I would have one tweet that would come out and say, you should really do this, and then 17, 18 different rebuttals that would come out and say, don't touch it. And in fact, there's many of the conversations that we'll look at today as well. So maybe one little example. So back in 25th of May last year, my birthday, I saw this tweet. It's 2019, you should learn GraphQL. I said, absolutely, why don't I share the love? So there I go, retweeted. 15 seconds later, Aaron Powell, he's actually one of my good friends, came back, it's just fancy OData. And while this is a little bit of a playful exchange, often the ones that I see are quite close-minded. And again, as a community, I really want us to be able to learn and keep our minds open. And it's not just on Twitter, but it's also blog posts. So this came out in 2017, and it's basically declaring REST as being defunct. It's calling it the new soap, that it's obsolete. At about the same time, we have other blog posts that are saying REST APIs are rest in peace, and that everything now that's building from now on should be GraphQL, which is a little bit confronting for me because I've spent 10 years of my life building REST APIs. Is suddenly all that information defunct and not valuable anymore? Surely not. But there's also this I got this strange sense of deja vu when I was reading some of these articles. And history has a strange way of repeating itself, and I actually think we've been here before. So if we were 2017 there, let's wind the clock back a little bit more, back to 2010. And in this case, Roy Fielding had just released his dissertation. REST was really on vogue, and we were calling SOAP dead, and that REST was going to replace everything about SOAP. Another article from about the same time. So SOAP is officially dead. Long live REST. So there's very many similarities here. So what can we draw from this? So if SOAP is dead and REST is the new SOAP, does that make GraphQL the new REST? Surely not. But yes, you see, GraphQL is indeed the new REST, part 1. I've never actually seen part 2, but I'm sure it will be fantastic. But the problem that a lot of these articles have is they're very pro one side, and they're not balanced. So again, when we want to take it to our companies or make a decision ourselves, I often feel we can end up making a choice of the technology itself, and not the properties or the characteristics that it imbibes and how it then matches to the problem that we have at hand. So I guess what can we learn from that? So we could be rather whimsically just say, maybe we just don't like XML and we get on with it. But I think we'd be missing a rather large point there, because really I feel the issue is deeper seated. I feel many of our API consumers, so the people consuming our APIs, using them every day, reading our documentation, calling them, are unsatisfied and frustrated. And I think that's a far deeper seated problem. So how can we build products that truly give the experience we wish? And our API community is small. So again, let's not get hung up on one technology or another. Let's work together and see, of all the tools that we have available to us, how can we work and choose the most effective one? So this all sounds a bit dreamy, doesn't it? So imagine if there were no protocols, no hypermedia hills to die on, no media types. Wouldn't that be a wonderful world? We wouldn't have to argue about technology at all. We'd all just get on beautifully. Unfortunately, that's not the way that APIs work. APIs, we need to have a contract between two parties. We need to have protocols and specifications such that two parties that are otherwise separated can have a conversation and understand the semantics and the syntax of the messages passed across the wire. There's no escape for this. So we will always be locked at looking at wire formats, semantic construct of our messages. So we need to do a way that we can understand them better and actually see some of the similarities between them. So to that, let's look at API technologies over time. And we'll start back in 1991 with a middleware called Corba. And this was an RPC framework, so remote procedure calls. So that's a phrase coined by Bruce Nelson, and one of the oldest styles of distributed computing interactions. And in fact, this was actually deemed at the time going to be the future of e-commerce on the web. However, it soon fell out of favor for XML, of all things. Then in 1993, remote data access got released, and that's a way of querying data from a database over a network interface. So if you're thinking from there, it kind of sounds like a query interface, and it absolutely is. So the client then defining the shape of the data that it was, it would get sent to the server would then process it, parse the query, retrieve the data, and send it back to the client. In 1998, we got a formal specification for RPC released by Microsoft, and that was based on XML. So finally, we had a strong contract for how to build these distributed systems. However, 1 year later, again from Microsoft, so Don Box, one of the authors of the 4 tenets of SOA, released SOAP. And SOAP, again, very much an RPC-based, and we had WSDL as the interface or the contract for it. And this really formed the vast majority of the APIs that were built in this early 2000 phase. So in 2000, we did have Roy Fielding released his REST dissertation, which imagine if we could build APIs that were in harmony with the web. And we had this little bit of to and forth for the next 3 to 4 years where they ran pretty much in parallel, sometimes SOAP starting to fade a little bit into the background and REST APIs becoming a bit more popular, mainly by companies like Twitter or Facebook that were releasing their public APIs at the time. In 2005, we see JSON starting to take over from XML. And in 2007, we see OData, so under the moniker of a better way to rest, so released by Microsoft again, very much in the same style as remote data access. So allowing clients a huge amount of flexibility in the queries that they shaped. So instead of a canonical URI, as the uniform interface in REST would define, we could have clients defining any shape of data they want. So incredibly flexible, so empowering the client rather than having it defined by the server. And that's a paradigm that was really embraced by GraphQL in 2015 as well, where they very much have mutations for the writes, which are actually very much like RPC, and then query APIs for the read side. So it's actually not that different to many of the other techniques that we've been using before. And then in 2016, we got the latest incarnation of an RPC framework, so gRPC, and very much a focus on performance and code generation. But again, very much building on what we saw with JSON RPC and XML RPC before it. So if that's the technologies itself, let's have a look at what was happening in the industry at that point in time. So when we were building APIs back in the early 2000s, it was very much for one provider and one consumer. And they were very direct stovepipe integrations. And this changed quite a bit with Web 2.0 in 2010, when we started to build APIs for many consumers. So instead of specialized for one consumer or one partner, you could then have many consumers. So falling more into a conformist model if you follow Eric Evans. And that was really a massive change. So instead of trying to optimize for one use case, we actually wanted very flexible APIs. And I think we'll see that continuing to evolve as we build richer, more complex systems as well and truly embrace cloud native. I think we'll see many-to-many interactions, so far more server-to-server lattices of APIs building. And again, I'll mention a couple of names as we go through, like Zdeněk Deník, who talks quite a lot about this next evolution of APIs. So across all this time and different techniques, we can still classify all of these technologies. And we can put them in buckets like this. So query APIs, where we want to empower our clients to retrieve the data that they want. And we're favoring flexibility. We have flat file APIs, very popular in the early 2000s. So EDI, or electronic data interchange. So still absolutely perfect, maybe if you have a flat file extract from your financial system and you need to do month-end reporting and it doesn't need to be real time, it is absolutely still a valid form of API. And if this is batch and asynchronous, then the streaming APIs are absolutely real time. So you can think about serving video or maybe stock price updates. But you think a lot of very rapid, potentially bidirectional communication across the wire as well. We have RPC APIs. So again, gRPC, XML RPC, but very much calls. And again, with the RPC paradigm, it's one component calling another component across a distributed network, but always pretending that that distributed network is not there. So we're treating that as a facade across it. Whereas with web APIs, we spit up a HTTP client, we embrace the web. And these web APIs is really where the majority of our REST APIs or HTTP endpoint APIs would land. So I guess if the overall aim of this talk is to say which is the best API style, I think I have to confess now, and it might be difficult the last talk on the last day to suddenly be told that there is no single best API style. Computing is hard, right? So there is always a best style for your problem at hand. And that's the key thing that I want to take away from today. Don't choose a technology and fit a problem to it. Let's look at the shape of the characteristics of your system, and then we can work backwards. But what would that process look like? So we can get some guidance here, again, from Roy Fielding, the man behind REST. And he says the properties of your system are induced by the set of constraints within an architecture. So REST itself defines a set of constraints. One of them is the uniform interface constraint. So with that, it says that any resource in a RESTful API can be accessed through a canonical URI. And then what you can do with it is then defined by the HTTP methods or verbs that are associated with that particular resource. And what we get as a property of that constraint is simplicity, that you have a uniform interface, and irrespective of the API, you know how to interact with it. However, there's a trade-off to it. Because we're putting in an abstraction, that could potentially cost us efficiency or performance. So again, there's not always pluses to these. We have to trade off some of the constraints. But it's not just about the architecture themselves. There's many other types of constraints that we need to factor into the systems that we're building. So there's business constraints. So who are you building for? Are you building to a customer who has their own release schedule that you can't align to? Maybe you don't have control or influence over it. Maybe there's specific capabilities. So if your customer is only capable of consuming flat files, well, good luck building a gRPC API for them. So again, you might have certain constraints that are defined by that, or performance constraints, scalability constraints. Then we can also have technical constraints. So again, how is this system going to operate? How is it going to be robust or resilient? Where do you trade off between the two? So again, looking at the 8 fallacies of distributed computing, thinking again, how do we build that characteristics, potentially in a cloud-native architecture, into the APIs we build? So again, very different if you were deploying to your own data centers. And then finally, we have the most interesting ones, all the human factors around our systems. So if we're building products, then how do we keep these products healthy and sustainable over time? So we have to factor in things like the knowledge and expertise of the teams. So unless your teams know HTTP really well, then it can be challenging to build a truly effective RESTful API. Because while it does leverage all of the semantics of the underlying protocol, there's the rub. You need to understand it inside and out. And that could be quite a steep learning curve. You also have to think about how you own those systems. So Conway's law and observation that says the systems we build will mirror the communication patterns within our organization. So how do we build our teams and align them to the products that we build? So once we take all of those constraints, be it business, technical, or socio-technical, we can then see all of the properties that will be imbued in the system, both around the ecosystem, so all of the operational concerns, but also then of the software system itself. And what I do whenever I'm designing a new system, I always start here. I always start, what are the properties that my system needs to have? How is it going to need to be security, scalability? What are other features that I need to do? And then once you have a clear idea of the characteristics of your system, then looking at what constraints you can apply that will yield those properties. So how might we be able to do that in a broader sense? So again, we have a bit of guidance here that says, while there's no best architectural style that's suitable for every problem, we can compare architectural styles by looking at the properties and again, looking at the constraints that a particular architectural style will apply. And this was actually my original premise for today's talk. So I was a little bit disappointed to find out about 10 minutes into my research that someone's actually already done it. So this gentleman called Denik Nemec, who gave the keynote at Nordic APIs at the end of 2018, has done a very good comparison between REST and GraphQL in a low level of detail that takes all of the constraints that are defined by REST itself and then additional operational constraints, and then also then complies it and contrasts it with GraphQL. And this is GraphQL of the ecosystem about 18 months ago, so some things have changed, but you'll still get a broad view or a comparison between the two. So again, from that, I will share this and all of the slides and resources afterwards, so no need to take photos as we go through. But we're going to do something a little bit different then. And we're going to go back and look at some of the conversations that are happening in the industry. And we're going to take these myths or blanket statements, and then we're actually going to ask a little bit more questions, and we're going to go that little bit deeper and see, is this actually true? Or to what degree? So first of all, let's go back to this article that I referenced in the first couple of slides that declared REST APIs are rest in peace APIs. Long live GraphQL. So clearly the author here saw no more value in REST APIs. And we have another article at the same time that said GraphQL would do to REST what JSON did to XML. Is it really that clear cut? So again, let's look at the thinking of the paradigms underpinning GraphQL. So on the query side, it is very much remote data access. And on the right side, it is RPC. So actually, really nothing incredibly revolutionary there. And it's actually got a fair amount of HTTP or REST semantics thrown in as well. And then let's have a look at gRPC itself. So again, a little bit different, but gRPC ties itself specifically to HTTP2. While GraphQL declares itself as protocol agnostic in a similar way to GraphQL, gRPC always uses HTTP2 as the transport. And HTTP2 is actually very specific here. Not HTTP 1.x, it has to be 2 as a minimum. And the reason for that is that it leverages a lot of the streaming capabilities of HTTP2 for its functionality. On the transport and schema side, it uses protocol buffers, or protobuf. And that is both for the schema, so the WSDL, you could think in a SOAP API, or an Open API, RAML, or API Blueprints contract in a RESTful API, and then also as the data exchange format over the wire. And gRPC is incredibly flexible for the types of interactions it supports between a client and the server. So it supports traditional request response, so one request from the client and one response back, also known as a unary operation, but also more complex interactions, such as service streaming. So one request from the client can yield multiple responses from the server. We also have the inverse, that the client can stream multiple updates to the server and then only get a single response back. Or we can have bidirectional streaming as well. So again, gRPC is wonderful for real-time interactions between APIs, where you have data changing very quickly and you need to have synchronous interactions or integrations between them. But if we look at REST, it's quite different again. So if gRPC and GraphQL are really data over HTTP, or data over the wire, REST is a state machine over HTTP, or a workflow. And this is a really key point. And when I talk about a state machine, what I'm really looking at is that word hypermedia. So again, the bit that always kind of throws people out, if you're looking at the Richardson maturity model, it's this thing up at layer 3. But it's actually not that far in a concept. It's actually everywhere. It's the underlying paradigm of the web. So if you just look at this really basic HTML page, we have hypermedia controls here. And in fact, we have 3 of them. First of all, we have an image tag, and the semantics of an image tag. So whatever resource is referenced by this URL, when we dereference it, it will take the contents of that and put it in the aligned space. We have an anchor tag that says when you dereference that link, you will then be navigated to that page. And we have a form which says when we submit it, it will take the data that we've captured in that form and send it to the server. So these are all affordances which have been sent by the server, which then have well understood semantics on the client. So in the same way we could have in a RESTful response where we can provide links to the client, and the client can then use the link relation and then follow that link to determine where can it go next. So if you have an approval process, so you might put in an order, and it might then go to a pending status. It might then be approved when you've taken payment and finally shipped. And at any point, you can control the next navigations or valid state transitions for it. So anywhere where I'm thinking that there is a flow, and I want to be able to then tie down the transitions between that, REST is a wonderful choice for that. And since, as I mentioned quite a bit about hypermedia, I really have to say this next line is that REST does require hagios, so hypermedia as the engine of application state. And I feel that this is quite an important point, and I don't mean it to be confrontational. I apologize if it does, but I feel a lot of the pain or a lot of the backlash that we're seeing about RESTful APIs or REST-ish APIs is that we've taken some of the parts of REST, and then other parts are a bit difficult, or maybe we haven't been able to implement adequately for a number of reasons, and it delivers a suboptimal experience. And I feel that's a lot of the tension that we're sort of seeing in the community right now. So I would really implore you, don't build REST-ish APIs. I'm firmly of the opinion that for many APIs, if for whatever reason you can't, maybe the use case for it, or the knowledge within the team, or the client, you could actually get a much better result by either building it in an RPC style or a GraphQL style. So far less effort and get a better outcome for it. And that's actually okay because, again, we shouldn't start by saying, I want to build a gRPC API and work backwards. It's just saying, okay, with all the constraints that I have, what's the best outcome that can have? So, and if your API is mostly actions, so an example of this could be the Slack API, It's an RPC API. It's heavily action-based, and a lot, again, the tension with REST APIs is where we have an action-orientated interface, and we try to squidge it into a RESTful URL, so we end up with this resource slash increment, or those sort of actions that you spend a lot of time bike shedding about URL structures. And yeah, I don't really feel it's that valuable. But if, however, your API is mostly CRUD, and you're manipulating related resources, or there is a workflow, then REST is a wonderful choice. And in fact, if there is one person you should read a lot of content from, and in fact, someone who I've taken quite a bit of content from their blog post is actually Phil Sturgeon. So you can take a lot from him. He writes a blog post called APIs You Won't Hate. And while he's got a lot of very strong opinions on a lot of things, there's a lot of experience behind it. So I thoroughly encourage you to follow Phil. And this is, again, just to prove that there's, even the creators of these technologies don't see them as being perfect for all use cases. This is Lee Byron, and one of the creators of GraphQL. And he says that GraphQL is a wonderful choice for client-to-server interactions, but he doesn't really see the value of it for server-to-server communications. So very much where you have a client that has, or maybe multiple clients with different data needs, that's wonderful because we're empowering the client to select the data that it needs. But for server-to-server calls, gRPC or even REST could be a far better choice. So, API styles. They address different problem spaces. If we're building REST-ish APIs, whether it be for internally within your team or to customers, consider whether you could get a better outcome for less effort with exploring GraphQL or RPC. And I'm not saying that they are better. I'm just saying that to build a REST API requires a high level of experience and dedication. And you often don't see the payoff in a short time, but it's really being able to evolve over decades is where the power of REST comes in. And that mightn't be the shape of your problem at all. So consider that. And gRPC is wonderful for synchronous communications between internal services. It supports many different interaction models, and you can get a huge amount of flexibility there. So another statement I saw that was being passed around quite a bit, and this one still comes up, is GraphQL breaks caching. But what kind of caching? Surely not all caching. Because if we look at caching, there's actually many kinds. We can either cache in the client, so that could be your browser cache. We could cache on the server side, also known as application caching. Or we can have network caching or intermediary caching. So again, cache boxes that might sit between the client and the server. So let's take a look at that. So with HTTP caching, we can have these intermediary caching proxies. So you can think Squid or Varnish. However, with GraphQL and gRPC, while we absolutely can still do server-side caching, so retrieve something from the database, maybe stick it in Redis, and then send it back to the client, or on the client side, we can still have, in the case of GraphQL, a denormalized client cache, or you could store it in the browser cache. But you cannot do the intermediary caching proxy. And that's for a number of reasons. Not only in GraphQL generally uses posts, which are cacheable. But why are intermediate caching proxies important then if we can still get a lot of the benefit from the server side of the client? And it really comes down to proximity to the client. So while the speed of light is fast, about 300,000 kilometers per second, it is not infinitely fast, particularly if you're going over copper wire. So again, where the refractive index jumps wildly. So again, if you can get your data closer to the client, they will get it more quickly. So again, from a performance perspective, very valuable. You could also then localize the data for a number of clients, prevent more expensive calls coming back into your network as well. So how about we start trying to achieve this support for intermediary proxy caches with GraphQL then? And there's been a bit of a shift in the community over the last year about it. And instead of using posts and pretty much using HTTP as a dumb pipe, there's now kind of championed by Apollo in the node space, so one of the providers there, allowing you to use queries with a HTTP GET request. And also using persisted queries, which are, again, queries that are pre-computed and exist on the server. So instead of having to pass large queries over the wire, you can send an ID and then have it hydrated on the server. But this is not part of a standard. So this is still very much things that have emerged from various areas of the community, which is a bit of a shame because that's actually one of the big power of GraphQL, that you had a specification for GraphQL, which removed a lot of the ambiguity or the challenges that people were building with REST, which was more of an architectural style, and there was no specification which we could implement. There is, however, no GraphQL specification for HTTP. So again, there's still a big lack. There's still a big gap there. So many of the cases for problems that have actually been solved by the REST community a number of years ago, decades ago, we're still solving them today in GraphQL. So there's still a lot of bike shedding that's happening in the community. Another thing to consider as well is whether your API is authenticated. So whether it's open or whether, again, you will have an authorization header with either a session cookie or a bearer token or some other form of identity or personalized data in there. Because what we should be aware of there is that intermediary caches will not cache authenticated traffic by default. So again, if all of your content is fairly real-time and tied to a specific identity, then that changes your landscape particularly as well, and actually intermediary caches mightn't be a concern for you at all. Okay, so we've already got a little bit of nuance. So breaks caching, but there's 3 different types of caching. Do all of them apply to me? Maybe not. And there's another thing that you should be aware of as well, is the more customizable your API is, generally the less cacheable it will be. So in the case of a REST API, where we have a uniform interface, we might have /user/1. And we'll get a very good cache record for that, because the second we retrieve that record, there's nothing else I could do with it. So the cached version, whether it be for expiration-based or e-tags, you can generally be served to other users as well, or other clients. However, the second we start adding query parameters to it, so maybe being able to select a subset of fields or put an order on it, again, we're creating a unique identity there, and we're reducing the number or the likelihood of someone else making that same request. And now imagine with GraphQL, where every client can make any query that they want. So that's a huge level of power that you're giving to your clients. So again, the cacheability of that will decline. So the more customizable you make your API, again, just consider that you will actually be losing or complicating your life on the caching side again. So everything's a trade-off. So actually, you might be thinking, actually, for the API I'm building now, caching isn't that important for me at all. So maybe I actually then veer towards one option or the other. So the takeaways around caching is that there are many different types of caching, and they apply to different scenarios. So highly customizable APIs where the clients are afforded a huge amount of flexibility in the data they request, they benefit less. If network caching is valuable to you, then absolutely looking at a RESTful API could be a really good choice, because you will be able to get data more easily to the edge. And best practices are absolutely still emerging for GraphQL and gRPC in this space. As I mentioned before, there's still a lot of the communities are still relatively immature in comparison to REST, so there's still quite a lot of bike shedding that happens in the area. This is one of my favorites. REST APIs are inefficient. What do we do with this? Like, how can you respond to it? And I think what we really have to start looking at is, what was REST for? Like, REST was never about efficiency. That was never its goal. So we were looking to build systems that could evolve over decades, so that client-server architecture where each could evolve independently. So we were looking for longevity and reduced client coupling. And in fact, many of the decisions that were made of the architectural constraints of REST absolutely went against short-term efficiency. Right? So that's a very deliberate choice for long-term flexibility and evolution. But that's not to say that when we say they're inefficient, that we should be conflated with that they're not performant, because there's absolutely things that we can do in this. And in fact, HTTP 2 has removed a lot of the pain that might have been associated with previous REST APIs using HTTP 1.x. But what are some of the major issues that we can see with REST APIs? So we can either overfetch. So if we have many different types of clients, maybe a web client or a wearable, a watch, those clients can generally display varying amounts of data. But if you only have one representation, then you might be sending way too much data to one client and then just sending slower requests, maybe using up their available bandwidth, maybe their data allowance. On the other side, we could be underfetching, which could typically result in, I'm going to retrieve the master record, and then for each one of its children, I have to dereference the children independently, often known as the n+1 problem. But there are techniques that we could do to tackle these. So for overfetching, we can use sparse field sets, so allow the client to specify the individual fields that it wants, or maybe field groupings. So again, while there's no standard around this, there's a number of options that you have. But effectively allowing the client to say, I don't want all of it, just give me a subset of the representation. And to avoid many round trips, we can look at compound documents. And compound documents are really the main aspect of some of the hypermedia types, such as JSON API or HAL, hypermedia application language, that were quite popular like 5-6 years ago as well. And they were really looking to mitigate a lot of the issues that we had with HTTP 1.x APIs. And this was really one of the first things where GraphQL came to the community and says, irrespective of the shape of the data that your client requires, you can retrieve all of it in exactly one round trip to the server. And this was seen as a massive boon. So instead of all these individual requests, we could now create one request, have it processed on the server, and go back to the client. Doesn't that sound brilliant? What we have inadvertently done, though, is now tied our response to the client to the slowest piece of data. We've coupled all of those individual requests. So if we have some data that could be retrieved really quickly for the client, maybe just the way layout data elements, and then we have some more expensive computed fields, all of that data will need to be available on the server before the client sees anything. So as people actually started building APIs, and I got stung this myself with GraphQL, and we started getting them into production, we actually saw that there was a lot of effort needed to be invested in tuning your queries, and actually then moving some of the computed items out from larger queries and actually making them separate items themselves, so that we were reducing the volatility of those requests. And again, where there's a will, there's a way. The community thought, okay, well, what happens if I could then mark certain elements as being deferred, which could then be sent back to the client as a HTTP patch, and then the server could then look at all of those items and finally stitch them up. It adds a lot of complexity, and what we should really be thinking at this stage is, should it really be this complicated? Like, where's that simplicity that we really want as well, if you're thinking about that simple customer experience? And if we really look at all of these compound documents, it was really a result of HTTP 1.x, where to establish a connection at the TCP level was very expensive. So we had window scaling, we had handshakes. Likewise, at the TLS level, we had to establish a new connection. So we had to have the server hello again. And that takes a lot of time to not only establish the connection, but also to scale up the bandwidth on that connection. So establishing a new connection for every request was very expensive. And then you could also look at techniques like domain sharding as well. But we were generally looking to get around the hacks or the limitations of the underlying protocol. And in fact, HTTP resolves a huge amount of these because we can now multiplex streams over a single connection. So you can have one long-lived connection and then many requests that go over it. So you avoid all of the hassles of, again, having to create the TCP connection and scaling it, and again, doing the TLS handshake as well. It's not only that, there's also another feature called server push. And what this allows the server to do is to push resources or representations to the client without actually having the client ask for them. So what you could do from here is, if the client was requesting users, maybe from there that you could also proactively push a number of the child records to the server as well. And from here, you're allowing the server to take a lot more control over how it can optimize the sending of traffic to the client. And in fact, one of the big goals of this was actually to have servers to optimize the loading of web pages. But we found that preload or prefresh links were actually a lot more effective on the browser space. But there's open source libraries such as Vulkan, which has been released last year, that now allows clients to send additional link headers in the request which the server will then push back to the client asynchronously, such that when it needs it, it will be available in the cache on the HTTP connection. So it sounds wonderful. This is something that I do expect will become more popular over time, but there's still a fair amount of profiling that we need to do on server push. In the links as well, I have included a link to that library called Volcane, but it's an interesting way where as API developers, we can now look at different ways of serving resources to the client. So performance. So with HTTP 1, the cost of a handshake was really high, and in fact, there was multiple handshakes, and we were doing them very frequently. And we created a lot of hacks or workarounds for that, typically compound documents. But when we made compound documents, we ruined the cacheability of those requests again, because, again, they were only as cacheable as the most volatile piece of data. Now with HTTP 2, we can send all those individual requests back to the client without having to create new connections. So we can do it a lot more effectively. And because we can still do it in a more granular sense, we still get very high cacheability from it. So it's actually a win-win. It's beautiful. And server push creates new possibilities, again, for potentially profiling the use of our APIs. So we're seeing traffic patterns where clients generally have this set of interactions, and again, having that data ready for when they use it. And in fact, gRPC heavily uses HTTP 2 full stop. And in fact, we will talk a little bit about gRPC web, which you might have heard in some of the Blazor talks this conference as well. And that's for streaming methods again, so one-to-many requests either originated from the server or the client, or in some cases, both directions. This is another great one. So GraphQL eliminates the need for versioning. So GraphQL, we don't need to version our APIs anymore. It's a bit odd because we never had to version our APIs. It was always a strategy. It was never a requirement. So why we would version our APIs? It was a strategy to handle breaking changes where you would change the contract on the server and you wanted to insulate a client from that effect. So then you could make a breaking change, create a new version, and then the client could decide when they want to adopt that new version. So absolutely a strategy. But there's other ways of handling evolving capabilities. And from there, it's graceful evolution. And this is really what has been promoted in the REST space for quite a number of years in the web as well, that web pages gracefully evolve in the same way we can build our APIs with non-breaking changes. And in my opinion, graceful evolution should always be the goal. So where possible, supporting multiple different versions of an API as a provider can get very expensive very quickly and complicates the landscape. So not only from a client perspective, but also from a server perspective, you could simplify your life a lot if you choose graceful evolution as your strategy. However, it does take discipline. So some of the implications of it is that we can't add new required inputs to an operation. We can't remove outputs or make them optional, because again, we could be breaking a dependency from the client. We can't change the type of a field. So if it was a string, we can't turn it to a number. And we should also be following the robustness principle, or Postel's law. So being incredibly broad in what we accept, but incredibly specific with what we send. So again, being well-behaved citizens. And this takes discipline. But while it takes discipline on the server side, you cannot treat it in isolation. And another massive call-out is you cannot over-communicate with your users. So even if you are going to make a change, don't rely on at sunset or at deprecation headers on your API responses and expect your clients to understand that a change is going to be coming. Send a bulletin, update them with change requests, let them know a number of months out. Particularly that works where we build a lot of partner APIs, so for system integrators, but also internally as well. And having a regular cadence where we can discuss API changes has reduced a lot of the friction around timing those. So if I spoke about the server previously, there's a lot that the clients can do as well to be well-behaved citizens as well. So if you're consuming an API and you only need 3 of those fields, don't break if the server includes an additional field that you're not interested in. Don't break if the server sends the fields in a slightly different order. So don't take that response and serialize it directly into a class. And this tolerant reader pattern is actually defined in Martin Fowler's book, Enterprise Integration Patterns, and it provides a lot of guidance about when you're consuming APIs, how do you make sure that you can do it in a robust way? And in fact, there's a number of other patterns in that book as well that can provide great insight into building resilient integrations between systems. But if we do need to make a change, and we want to deprecate a certain feature, how we communicate that? So I've already mentioned about deprecation and sunset headers on the response. GraphQL actually comes with an inbuilt feature around this, and it's called deprecations, where I can mark a certain field as saying this will soon be removed. And because GraphQL, you know exactly what fields or what data every client needs, you can create a map of who would be interested or who's using this field and who should I inform if I'm going to change it. And that sounds wonderful. And in fact, this was something that I was really excited about, because I kind of expected I'd be able to then have really targeted conversations with a subset of my users and say, this field's going to be removed. Are you OK with that? Can we work out with the timing? But unfortunately, when your API reaches a certain level of scale or a certain number of users, as kind of observed in Hiram's law, everybody depends on something. So you'll always have users that require at least one of the fields. But there's also implicit dependencies as well. So behavioral systems as well, or behavioral functions in it. And that's not always something that you might document in your API. So you have to be really careful when you're thinking about evolving your API, that we're not just thinking about contractual changes, but that could also be behavioral changes in your APIs, which clients have a dependency on as well. So it becomes a lot more complicated than simply looking for a deprecation tag. And in fact, in many cases, if you're looking to do a migration to a new service or a new version, sometimes you have to deal with bug-for-bug compatibility because you can't control for those clients. Even if it doesn't behave exactly as it was originally documented, that was the expectation the client now has. So if you're doing any refactoring of existing systems, so again, dealing with legacy code by Michael Feathers provides a lot of guidance around how to deal with these integrations and breaking out separate components. But the biggest thing we can do about leveraging this is about defining the interfaces. So making systems evolvable starts by getting the interfaces right. And if we don't do a fair amount of upfront design, then we are in a lot of those change request sort of landscapes where we're making breaking changes for clients. So the biggest thing that I could advise around this is using a contract-first design approach. So what might that look like? So in GraphQL, that's your schema. In gRPC, that's a protocol buffer. And in a REST API, you have a whole plethora of choices. So you can have Swagger, now known as OpenAPI, RAML, Blueprints, a number of others. But starting with a common contract that can then be developed in parallel, maybe by different teams of building a client, maybe actually building out the API implementation. And because you have a contract, it's very easy to mock against that contract as well because you have that shared interface. And then when both of them are ready, they can be integrated, and then the loop can continue again. And we found, again, by starting with the contract, it was very easy to evolve that and have shared design sessions between the consumers and the producers, rather than having to write code, and that feedback loop became longer and more onerous. So again, be able to create an environment where it's really easy to change and update that behavior quickly, we found paid off in the long run. So versioning, it is a technique to manage breaking changes. It should be a last resort. It shouldn't be your first option. Only use it where absolutely necessary. Prefer graceful evolution. Absolutely not a substitute for communicating with your users. That is the absolute biggest thing about managing changes in your API. And it doesn't protect users from depending on implicit behavior as well. So sometimes it's not just about the interface changes. Another one we came across was domain modeling is purely a REST concern. So if I'm using any other style, I don't really have to worry about it. And that's so not true. If you do that, you're going to have design issues from day one. So always start with your users in mind. So both gRPC and REST start with an outside-in approach. The server defines the shape of the operations of the queries, and then you start building them out. And GraphQL allows you to take a slightly different approach to this. So if you were building a system and you weren't quite sure about the interaction patterns of your clients, you could actually get a little bit of a benefit with GraphQL in this, because GraphQL delays the responsible moment of identifying your query needs to actually profiling those queries. So with GraphQL, I don't actually define individual endpoints or operations to call. Rather, I define a graph of data, and each query then maps to a subsection or tree of that graph. So we're not optimizing for an individual use case, but the risk you pay for not putting that up front is, again, having a higher cost or complexity about profiling those queries later. But again, it's a good tactic to deal with uncertainty, or if you're going to have multiple consumers, each with very different needs. So API design is absolutely table stakes, irrespective of the style. Both REST and gRPC follow an outside-in approach where you have to define the operations on the interface. GraphQL is different in that and can let you deal with uncertainty in a slightly different way. And it really allows you to then see how users are actually executing against the graph at runtime. But again, there's an inherent risk in that too. So if that's all the myths that we looked at, let's now take a quick look in the 8 or so minutes that we have left across some sample scenarios. And given what we've seen about architectural decisions and a few of the blanket statements that we've got made, let's see if we can land on appropriate technologies just to get some of you thinking in terms of some of the use cases when you go back to your offices next week. OK, so first up, we might have the absolute simplest thing we could do, just an application web form. So it might be for applying to buy a ticket or something like that, or buy a ticket for an event. I don't see personally why you would use anything other than REST for this. I see many teams building building GraphQL APIs for very simple things like this. But here, all we're doing is taking a certain amount of data. It's a write operation, and then sending it back to the client. Unless you have wildly varying data querying requirements, I think there's simpler options for it as well. And in fact, again, I think we'll see this is the year that a lot of malcontent will start growing with GraphQL APIs where we've built them, maybe not for the appropriate use cases, and that would be burned by trying to tune or operate them, or the overhead and the inherent complexity of them. So really understand about what's the simplest API approach that you could have for your problem at hand. Another case that comes up quite a bit, particularly when I've been working with clients who have built highly granular services, sometimes called microservices, and then looking at how do you actually take that impedance mismatch of a very granular set of APIs here and then versus what a client needs in an SPA. And this is typically where we would put in an aggregate API, or maybe a backend for front end where we can aggregate a lot of the calls and then send it back to the client. And in fact, this is a place where GraphQL absolutely shines because it allows you to connect data from many different data sources. So it could be a relational database, it could be a graph, it could be a file. GraphQL is absolutely agnostic of the data source. And that allows each one of the clients to then query the data that it needs, and it gets optimized over the wire. So in many cases, we see putting in GraphQL as a layer over an existing set of services to optimize the delivery to different digital channels as being a very sweet spot for GraphQL. And typically, GraphQL can be brought in after teams have felt pain with an endpoint-driven approach, where maybe we didn't profile or define those endpoints appropriately, so we're having a lot of over or under fetching happening with those clients. And that's actually a pattern that we followed in quite a number of our consulting engagements as well. And that also allows you to then create an abstraction point where you can start refactoring some of these implementations, again, without affecting the client. So again, decoupling change. So if that was web, what about mobile? So if we want to have a BFF, so again, a backend for front end, and in this architecture, the API is actually owned by the client team. And this is something I've been playing with quite a bit myself, and I'm actually thinking that gRPC is actually a wonderful fit for this, particularly in the native space, which I'll explain in a little bit. Because what this can let you do is get one protocol end-to-end in your stack. So you can have one place where you share all of your proto files, and then be able to do all of the code generation of all those files themselves. And the beauty with a native mobile app as well is that you can use HTTP2 end-to-end. Whereas there's an issue with gRPC, and that's in the browser space, where the browsers don't expose an API to the sufficient level of granularity to ensure that you use HTTP2. So we can't actually use pure gRPC in a browser. or if you're in a web component or a Blazor app as well. So there's a couple of techniques we could do, but particularly in the native space, gRPC is a really nice fit. So for microservices, so again, I'm not going to say in this particular case any event-based microservices. So if you're looking for synchronous coupling, so again, more orchestration style, then again, I see a huge amount of value in gRPC and the code gen, particularly if you haven't standardized your runtimes. So if you're looking at having maybe some of your APIs written in Java, some in C#, some in C++, any other language, having a protocol file or protobuf defined and then be able to code gen the client to the server side and keep them in sync that way is a very powerful pattern. But what can we do then about gRPC in a web app? And there's actually a companion protocol to gRPC, and it's called gRPC Web. And it is actually quite different, because the purpose of gRPC Web is to enable you to create compatible gRPC traffic over HTTP 1.x. So that's really the goal. So for environments where you can't guarantee HTTP 2, then you can use gRPC Web. So what does this look like? So typically, you would have a browser, or in fact, it could be a server-side like an app service in Azure, because that doesn't let you support HTTP 2 yet either. So you could actually think of it as an outbound call from an app service as well. And then you could start with gRPC traffic, gRPC web traffic going to 1.x, and then typically you would route that through a proxy. So it could be Envoy, which is the data plane sidecar in Istio. And that will then convert the HTTP 1.x gRPC web traffic to true gRPC traffic. But you are looking at introducing a separate gRPC proxy. So 2 days ago, James Newton King released quite an exciting post saying that in .NET, they actually now created an experimental package that allows you to issue gRPC web requests directly and have them hosted and have them served by a server without an intermediary proxy. So that means that you could have an SPA or you could have a Blazor web component app, make a call to an Azure App Service over gRPC compliant traffic, albeit gRPC web traffic. And what this lets us do is get that common protocol buff driven workflow. And then when the work to complete gRPC support for app services become available, it can be a transparent change. So it allows you to adopt some of these techniques now. This is absolutely still an experiment, but I'm quite excited about the separate piece of infrastructure being removed. There is a gotcha with gRPC Web, though, is that you lose a couple of the interaction types. So bidirectional streaming and client streaming are no longer options. You can still do unary calls, or you can still do server streaming, but you don't get the benefit of options. OK, so what have we covered in today's talk? So we started by looking at API technologies over time. And we actually saw that there's a huge amount of similarities between them, where a lot of it is remote data access and then some form of RPC on the right. So there are actually a lot of the arguments or a lot of the discussions that are happening in the industry are actually about what's different, not what's the same. From there, we dug into a number of the conversations that are happening in the industry, and we peeled back a little bit more data so that if you're looking to choose one of these technologies, that you can get past that first, it will never work because, and be able to have better conversations around it. Finally, we took a very brief view at some of the major use cases that I could see in my experience where I used one of these technologies or not. But please, I really see a successful talk as being a sales pitch for your future time. So if I've encouraged you to look into one of these technologies or learn a little bit more or have an effective conversation with your teammates, then that would absolutely be a wonderful outcome for me. So thank you so much for your time. I do realize there was a lot of competition as for all slots, so I really appreciate your attendance. Thank you.